SQL enables us to get more out of our data in a better and optimized fashion. In this video, let me share with you some advanced SQL concepts as well as 10 practical data analysis queries. Let's go. For the purpose of our advanced SQL concepts, we are going to use the Sakila sample database that is available in MySQL. You can go to the MySQL workbench and activate the database Sakila, and then from there we are going to do these 10 queries. I've also got 2 homework assignments for you as part of this exercise. We'll get more into this in a minute, but first let me explain to you a key concept when it comes to doing advanced SQL, and that is understanding the structure of your data. So for example, let's say you started new in this company and you have inherited this database that has all these 10 or 12 tables. Now, before even you could do any queries, it will be important if you actually know how these tables are all set up and what is the relationship or linkages between them. This sort of a thing is called ERD, or Entity Relationship Diagram. Don't let the technical words confuse you. It simply means what are various key ingredients of the data, that is, what are main tables, views, and any other things. How do they link up with each other and what do they do? If you are using MySQL Workbench, you can quickly generate ERD for any database using these steps. Just select the database and then go to Database Reverse Engineer. You can also press the shortcut Ctrl R for this. Just make sure that you have selected the server to which you want to connect. In most cases, this is going to be your local instance of MySQL router, but you may also want to connect to a remote database if you want to reverse engineer that. Click next, and then select the database that you want to connect. So in this case, I want to use the Sakila schema to explore. If you want, you can also select multiple items here. For now, let's just select Sakila for this purpose. And when you click next, it'll go through its thing and it'll identify all the tables. So there are 16 tables, 7 views, and some MySQL routines and other stuff like triggers, etc. are there. And let's execute this. This is gonna understand the data and do a lot of things, but it's also gonna create a ERD for you in the background here. When you click next, it'll give you a summary and finish. And bingo, here is my ERD for the Sakila database. You can scroll through this page. You can also zoom in using this zoom buttons here. Let's zoom down a bit and we can see the entire ERD in one screen. It's too tiny here, so I'm gonna zoom in a bit and we can explore all the tables and understand how they link up with each other. For example, let's take the table customer. As I point on it, you can see there are lots of lines going from customer table to various other parts of the database that tell me that what are the various things that customer is interacting with. So for example, the customer table has got a line going from there to store table. So there is a relationship between customer and store. A customer belongs to a store. So here is my customer and here is the store table. Likewise, whenever a customer makes a payment, that information is maintained in the payment table here. So you can point on any single table and then see all the relationships that are going there. Likewise, you can also point on a line to see what is connected where. So for example, let's point on this line here and we can see that this is connecting the film and film actor tables. A film will have some actors, so obviously all the actors of that film are maintained in the film actor table here. And likewise, you can kind of follow the thread to understand the relationships and structure of your data. When we talk about the relationships in the table, there are 2 more things that we need to understand, and that is a primary key and a foreign key. In order to better understand these words, let's first look at something like customer table. In the customer table, each customer will have one row. So customer ID here, for example, would be the primary key. It uniquely identifies each customer. So if I have got two different customers, they will have different customer IDs. And this sort of a thing is called primary key because it is the primary identification for a customer. So if this is a primary key, then what is a foreign key? Looking back at the customer table, when I highlight it, you can see how many different tables it is connected to. And let's take a look at the payment table. A payment can be made by a customer. So customer ID also appears in the payment table here. But payment table doesn't own the customer ID. It only maintains a connection of the customer ID. The actual ID and all the customer information belongs in the customer table. So this is where customer ID, when it is listed in a different table, is called as a foreign key. In a way, this is the identification number here that tells us who is the customer who has made the payment. If I want to know more about that customer, like what is their email address, maybe I want to send them a receipt, then I need to follow the thread from here to there and then get the email address. So this is why when you are understanding databases, it is important to know what is a primary key and what is a foreign key. There are also many other technical terms in the world of databases. I recommend checking the link in the video description to get a glossary of all the important database terms. You can use the ER diagrams in MySQL Workbench or any other tool. So for example, here is the ER diagram of our Awesome Chocolates business. And this is from the SQL Server Management Studio, SSMS. To generate the ER diagram in SQL Server, you can just select the database, right click and select that. And then from there, you will find that there is a database diagrams option. So for example, if I expand this, you'll see that there is a database diagrams option. You can right click on that and then select a new database diagram so that you can generate the diagram of your existing database. In case of Awesome Chocolates, it is a much smaller business in terms of database complexity. There are only 4 tables. We've got the central shipments table and people, products, and geography tables that all connect to it. Each software represents these ER diagrams in different way. So for example, here you can see the lines look slightly different and primary keys are identified with this yellow colored key icon. Now that we understand the ERD of our Sakila business, let's go and write some SQL queries. Here are the 10 SQL queries that we are going to write. We will go one at a time. And I have also provided a blank query file for you in case you're feeling adventurous and want to develop these queries as I explain them. Our first query is all films with PG-13 rating with the rental rate of $2.99 or lower. Let's first take a look at all the films. We can do that by right clicking on the film table here in the Sakila database and then saying select rows. A quick reminder about the MySQL Workbench. There are 4 main areas that you need to know. One is the schemas area on the left. Then you have got your query area up top with the result grid underneath that and a output window that tells you the status of your queries. Let's take a look at our select query result now. This is gonna show me all the films that I have. You can see what we have here. We've got film ID, title, description, release year, language ID, etc. And we have the rental rate here, which is 0.99, 4.99, 2.99, etc. And then further here, we have got the rating column that says what kind of rating this is. So here, what we are interested in is the PG-13 films that are available for $2.99 or cheaper. So to do this, we can write the query like this. Select, as we want to see all the data, I'm going to say star from film where, and we need to write 2 conditions here. One is the rating is PG-13 and another is rate of the movie rental is 2.99. So it's a good idea to remember what columns are there, and as this is kind of like a made up database that is available, it's hard for me to memorize everything. So one trick that I normally use is I expand this table in the navigator here and then expand the column. So I'm looking at all the column names as I develop the query. Alternatively, you can also, for example, give this table an alias. So for example, you can say select star from film F, and then you can start by typing F dot, and it will give you a listing of all the field names. So here what we want is, we want to look at the rental rate less than or equal to 2.99 and f dot rating is equal to, and within single quotes, PG-13. And we'll finish the query by using a semicolon here. Let's select all of this and run this, and we'll see all the PG-13 films that are available for 2.99 or less. Every time you run a query, if you say there is no limit, here you can say don't limit, or you can also limit to 10 rows, 50 rows, like that. Normally when you are practicing SQL, it doesn't really matter, and you can set a limit of 500 or something so the queries can run fast. But if you're running it against a large database, then I highly recommend setting the limit so that you're not really slow. After running the query, you can also look at the output area here to see what happened and if there is any errors. If you see a green tick, that means there is no error and we did get the result. And for example, here, the rating query has returned 146 rows. This number will not be accurate if you have a limit on the query. Right now I'm not limiting, but let's say if I limit to 50 rows, see what happens. I will only get the first 50 films, even though there are 146. So here I have got 146 rows, all of them listed, and I can browse through this data, or I can go ahead and add more conditions. In the films table, we also have a special features column that tells us what else is available on the DVD. So we have got trailers, behind the scenes, deleted scenes, etc. So our second query is, I want to see all the films that have deleted scenes in the special features column. Now keep in mind that the special features column can have the words deleted scenes anywhere. It could be at the beginning, middle, or end. In that case, how can we write this? We can say select from film F. And here is another trick that I normally use. I won't define the field names. First, I'll define the table name and alias, and then I'll come back and then I'll say F dot and then select all the fields that I want. So for example, I want to know the title of the film, film dot special features, film dot release year. These are the only three columns that we want. And then the condition here is where f dot special features like, and then within single quotes, percentage deleted scenes percentage. What this tells is I want to see any film where the special features column has that word. Before it there can be anything, after it there can be anything. Let's test this out. We can select this query and run it. And we're going to get all the movies that have deleted scenes. So there is again, there's 503 rows returned through that query. So a lot of movies have deleted scenes. Let's say I want to see all of these movies that are beginning with the letter C. I can add one more condition here. I can say and title like C percentage. That would be much smaller list of 49 movies. And here are them: Cabin Fish, Caddyshack, Jedi, etc. Our third query is about active customers. In the customer table here I'm selecting everything. You can see that there is an active column that has 1, and some customers are no longer active. Probably they don't want to do business with us anymore. So we have 0 there. I want to see all the active customers. This is a really simple query. You can simply say select star from customers where active is equal to 1. We didn't get any answer here. Instead, I'm getting an error. This is because the table name is actually customer, not customers. So once I adjust that, we will then see all the active customers. You might be thinking, okay, I don't want to see the active customers. I want to know how many active customers are there. Take it up as a small mini homework for now. I will actually reveal the answer of that later on in the video. Do keep in mind that I do have some full homework problems for you, so feel free to attempt them as we go along. Our fourth query is names of the customers who rented a movie on 26th July 2005. Now this is going to be a bit tricky Because if you look at the customer table, we know what the name is, but it doesn't tell us when they are renting from us. Let's go back to the ER diagram for a minute and let's take a look at how the customer flow is. Okay, I have moved around some of these tables so we can isolate the customer transaction side of things. As there are lots of tables, sometimes it is hard for us to understand where everything is going. So we're going to focus on this little area of the screen now. Let's zoom into that. So we have a customer table that tells us who the customer is. If you remember, the query that we are trying to do is, I want to know who are the customers who rented a movie on 26th of July 2005. A very specific query. So if I go here, in the rental table, I can see all the rentals that are happening. So for example, if I'm looking at the rental table, I can use the rental date and filter it by saying where the rental date is 26th of July 2005, and I'll see all the rentals. But in the rental table, I only have customer ID. So just the foreign key, we don't know who the customer is, what their name is. In order to get the name, we need to follow the thread from here to there. See this line here that connects customer on both tables. So we'll need to follow that to get to the customer table and then find their name. So that's what we are going to do. But eventually, once you know that, you can also do the same and get the name of the film as well. For that, you will need to go to the inventory table, find out the film ID, and then go to the film table and then extract the title and then use it. These kind of operations are called joins, where you're combining information from one table to another. We'll start with a simple example. Later on, we will add more layers of complexity to it. So first up, we will figure out who rented on that date, and then let's add the name to that later. So we can say select star from rental. I'm going to alias this as R, where R dot rental date. Now rental date, if you look at the rental table here, is actually not just date, it is both date and time. So we have got time component as well. We don't care on which time of the day they rented the movie from us. As long as it is that date, it's fine with us. So we would like to take this rental date and send it to a SQL function like date that converts the date time value to date is equal to, and then within single quotes, 2005-07-26. This is the date format of SQL. You have got year, month, and day. And if I run this query alone, I should see all the transactions, all the rentals that happened on that date. So here it is. We have got 33 transactions that happened. And these are the IDs of the customers. Remember, we don't want the IDs. We want to see the name. So now I'll need to join this with my customer. And here between the select and the where clause, we write the join clause. We start by saying join customer C on C dot customer ID is equal to R dot customer ID. This is how you specify the join condition. We'll start by saying the word join, the name of the table that we want to join. In this case, it's customer table and our optional alias, and then specify the criteria with the on keyword. On, and then what is it that we want to match up. Customer ID here should be customer ID there. Now that this is done, let's go back here. This star is not going to work. Instead, we are going to define the columns that we want to see. So we want to see, for example, R dot rental ID, R dot rental date, R dot customer ID, C dot customer first name, C dot last name. Enough for now. Let's try this out. And we're going to get all the names of the customers that took a DVD from us on that particular date. So for example, here I can see Gordon Allard took 2 DVDs on that day, 470, same customer. And these are the 2 different rental IDs from them. Now let's say I like this format, but I don't want to see first name and last name as 2 columns. I want to see them together in 1 column. To do that, we can use the concat function in MySQL. Here is how you can do it. I'm going to add a new line here and then say concat, open bracket, first name, comma, and then I want to also add a space in the middle, comma, last name. So that's the output. And when you run this now, you're going to get a combined name like that. Notice how the column title is the actual concat function. This may not be a good way to look at it. So you can also set up an alias here like full name in single quotes. And when you run this, you're going to get that as the title of the column. As you can see here, we have got a few customers who are borrowing more than once. So for example, here Justin No, as well as Gordon Allard further down, but there might be more people. So our fifth example is who are the distinct customers, all the names of such customers who rented a movie on that date. And this is where SQL again offers a simple option to do this. I'm just going to copy this query, Control C, and paste it here, Control V. So this query as it is, if I run it, I'll just get the same result. But this time I don't want to have all of this data. I just want to have a distinct list of customer names. So here we're going to take out some of these columns because they're no longer relevant. And this is what we are getting. And here I think I can say distinct as a keyword before the customer ID. And then let's try this out. So this one is going to give us all the distinct names. Let's compare the results. Here we can see the first one gave us 33 rows and the second one gave us 31 rows. So there's 2 less rows. Obviously those 2 duplicates have been removed. Time for our first homework assignment. How many distinct last names we have in the data? So I'm not interested in a specific date. Across all the customer table, how many distinct last names are there? Try it out using the SQL understanding that you have gained so far, as well as some other things that you can figure out yourself. Leave a comment to tell me how your query is for this. Our sixth query is how many rentals we do on each day. So now, so far we have been looking at the data and just trying to see everything. But the sixth one kind of adds a flavor of data analysis that we do with SQL. Given all of this data, how many we are doing on each day? Let's say you don't want to know how many we are doing. We just want to see all the rentals. We could write select star from rental. And when you run this, and if you say don't limit, you're going to see all the rentals. And if you go to the output window here, you can see that one has 16,044 rows in the data. So we have got quite a lot of rentals. Like I said, we don't want to know this at the all level. For each date, how many rentals we are doing. So here we can use a concept called group by. This is where we take a column and then group it so that for each group of that column, we can see counts or sums or other kinds of summary. If you have done some Excel pivot tables or other kinds of things, this is like pivoting the data. To do the grouping, we can simply say select star from rental. We'll need to adjust this star later, but we can use the word group by, that is the keyword, and then specify the column on which we want to group. We want to group on the rental date, but remember this is a date time and we just want to group it at the date level. So I'm going to say date of rental underscore date. So that is where we are grouping, and we'll come back here. We'll say date of rental date, and then we are going to name that as D. And on each date, I want to know how many rentals we are doing. Each row in the rental is one rental. So we just want to count how many rows are there. And this is where count star will help you. It just counts how many items are there. Let's test this out. And here we will get on 24th of May 2005, we did 8 rentals, then 137, 174 like that. We operated until end of May and then we didn't open the store for a few weeks. Then again it picked up. Here is a bonus homework question for you. Can you find out through SQL what is the busiest day in our business, the day with most rentals? Our 7th example is I want to know all the sci-fi films in our catalog. Again, to answer this question, we need to go to our ER diagram to see where this information is maintained. So if I go to the ERD here, let's zoom out a bit. We have got information at a film level, but we don't know what category the film belongs to. Let's go back here and look at the film data. You can see that the film has a film ID, title, description, etc. But we don't know what category it belongs to. In order to know the category of a film, we will need to go into a different table. And that table is the category table. Here I have got category table. This table lists all the categories, and there is a film category table. It is kind of like a mapping table that tells us what category each of the films belong. As a film can be both comedy and horror, it will have multiple rows. So what we want is, we want to use these three concepts here. The film concept, the category concept, film category concept, and the category concept, and then figure out all the sci-fi movies. Here again, you notice that in the film category table, we only have IDs. So our journey begins from the category table. We'll need to first figure out what is the ID of the sci-fi category, and then get all the films, and then get the names of such films. Let's attempt this. First up, let's take a look at the category table. Select star from category. And these are all the categories. You can see sci-fi is actually category number 14. So for example, if I were to do this manually, I don't know much SQL, then the next step for me would be, I'll go to select star from film category table, where category ID is equal to 14. And that's going to tell me all the film IDs that have 14 as the category ID. Then it's a simple job of taking these film IDs and looking them up in the film table. But as you can imagine, this is quite cumbersome and tedious to do. So we will want to do all of this through one query. And as we have three tables, the join needs to happen 2 times. So we're going to start our journey from the film category side. We're going to say select from film category, and then I'm going to call this as FC and come back here and then say FC dot film ID, FC dot category ID. Those are the 2 things that we're going to pick from FC. We're going to join this FC table with the category table. So we're going to say category C on C dot category ID is equal to FC dot category ID. Now that this and that are joined, I can use the options in the C table. So for example, here if I say where C dot name is equal to sci-fi, I hope that's how it is spelled. Let's run this out. We'll get the same kind of a result, all the 14s. And as C dot name is also available, we can list it in the listing here. So all the films and the category name comes up as sci-fi. Remember, we also want to see the name of the film. So let's go ahead and join this with the film table. So here one more join film F on F dot film ID is equal to FC dot film ID. So as the film is now joined, I can use the fields of F in my query. So fc.film ID category c.name. Likewise, I can say f.title. And then if I want, I can also use release year or any other information. Let's try this out. And here is a listing of all the sci-fi movies in our catalog.
I finally invented something that works!
If you tried this yourself, how did you do it? Let me know in the comments. Our 8th query is customers and how many movies they rented from us so far. So here I want to look at it from the customer perspective. For each customer in our database, I want to know how many movies they have rented from us in their entire life of doing business with us. Let's try this out. Again, it's a good idea when you're trying to answer questions like this is to refer back to the ER diagram from time to time so that you are clear where the relationships are going and how to set up your joins, etc. In this case, we are going to use the rental table. This is the main transaction table that kind of binds customer and inventory. And if I go here and use this information, I should be able to pretty much get what I want. So for each rental, we can count that as one row. So let's say we'll start from select from rental R, and what we want to see is R dot customer ID and then count star. Each time customer interacted with us, we'll see how much is that, and this is going to automatically kind of show that information at customer level. If I simply say at this point group by R dot customer ID, we are going to see for each customer how many times they have borrowed from us. So customer ID 1, 32 times, 2, 27 times, like that. This is kind of like simple enough, but we don't know who these customers are. So let's add their names and everything here. So here we can join customer C on C dot customer ID is equal to R dot customer ID. And now that customer is joined, we should be able to introduce the customer side of the story here. So for example, I can say C dot first name, C dot email, and then count star. Let's test this out, and I hope it works. And now we can see who these customers are and how many times they're borrowing from us. As we want to know the customer side of the story, it might be a good idea to sort this on the count. So I'm going to add an alias for the count and order this by count star. And let's do descending order for that. So here we can see Eleanor is our most popular customer, 46 units she has borrowed. She or he, Carl, then Clara, Marcia, etc. And all the way at the bottom, you'll have all your 30s and 20s and 12s. So here we have Brian, 12 times they have borrowed from us. Our ninth SQL example is an interesting one. Let's say as a data analyst, you are asked by your boss, looking at the entire film catalog that you're carrying, which movies should we discontinue from our catalog? And the criteria that they have defined for you is less than 5 lifetime rentals. So if a movie is really unpopular, nobody is renting it, then probably there is not much value of carrying that in your inventory. So how do we go about this? Let's try this out. We can look at the rental table. That's the main transaction table that kind of links up inventory and customer. And then start by asking the question, what is the number of times each inventory ID has appeared? This in itself may not be sufficient, and we may want to start the analysis from the film perspective. This is because let's say you have got a film that is never rented. Then what happens is the data for the film will be in the film table, but it will never appear in the inventory table, or it will appear in the inventory table, but it won't appear in the rental table. So you may want to start the analysis from this direction, but let's say for the sake of simplicity, we are going to look at it from the rental direction. So we'll start by asking the question, select from rental R, and what we want to select is inventory ID count star. And then we want to group this by inventory ID and then order this by count star. Let's run this part first, and that's going to give you every movie, and as order by is by default in ascending order, you're going to see a lot of 1s and 2s up front, and then further down you're going to see 3s, 4s and 5s. In fact, 5 is the highest number of times anything is borrowed. So I'm thinking if we discontinue less than 5 time lifetime rentals, then we'll discontinue everything. At least that's how the data looks. So I'm going to update this as 1. If it is rented less than 1 time so far, then we're going to discontinue that because it looks like it's an unpopular one. So essentially we want to know what are the names of these movies. So now that this bit is done, let's go ahead and figure out the rest. To do that, first we need to filter this query by these movies. That means the count should be less than or equal to 1. So here after you group by, you can also say having to specify a criteria on the totals that you have calculated. So having count star is equal to 1 or less than or equal to 1. Well, it is, if it's 0, it won't even appear here. So we can simply say equal to 1, and let's run that, and we are going to get these movies. But each of them, I want to see the name of the movie and maybe some other information. So from inventory, we'll need to go into the ER diagram here. From rental, inventory ID, I want to go into the inventory table to figure out what is the film ID and then get the name of the film. As we have already identified the movies, we can just delete the order by clause, and this is the main query that we are going to use. And for this, we are going to use a technique called CTE, or common table expressions. The way this works is we define a query that we want to use as a building block. So in this case, this query, and then we will create a variable to hold this query. You do this with the with keyword, with, and then the name of the variable. I'm going to call this variable as low rentals as, and then open bracket, close bracket, all of this. Normally when you use this, it's a good idea to kind of set up an indent like that so you can quickly see what this is. So with low rentals as this, and now you have got a variable that kind of holds low rentals, but that variable is a table. So you can refer to that table elsewhere. So for example, here underneath, I can simply say select star from low rentals, and it appears like a table to me at this point in time. And when I run that, I'll get the same result, but through common table expression. Now here, we don't want to do that. Now that this is available to us as a variable, we can then apply some joins. You might think, why can't we join inside here? But normally this can get a bit tedious to join when you have grouping. So it's a good idea to define CTEs like this so that you can break your query into smaller chunks. So here I'm going to say select, we'll take out that, and then join. And first up, low rentals need to be joined with the inventory. Inventory I on I dot inventory ID, the name of the field, is equal to, and then it should be same as this, low rental dot inventory ID. And here let's add those fields now. So we want to have low rentals dot inventory ID and I dot film ID. So at this point, from inventory ID, we should be able to go up to the film ID level. If I run just this much, you'll see all those 4 inventory IDs and the corresponding film IDs. Now that the film ID is known, I can go to the film table to figure out what is the name of the film. And here one more join film F on F dot film ID is equal to I dot film ID. And we'll come back here and then add the F dot title to see the name of the film. Let's run this all. So these are the lowest moving films in our store. These 4 movies, Galaxy Sweethearts, Mixed Doors, Musketeers Bait, and Rocky War. And maybe we should discontinue them. Our last example of advanced SQL concept is which movies are not returned yet. So this is a little bit tricky as well. Let's go back to the ER diagram to understand where we have to go. We have to look at the rental table and see if the return date column, this one here, is blank. If it is blank, that means that rental has gone out but hasn't come back in. So from there, we can figure out what inventories it belongs to. From the inventory table, for those inventories, figure out the film IDs and then go to the film table, join on film ID, and then get the title of the film. So that's the journey that we have to take. We can also continue that journey towards the customer direction and use the customer ID here to figure out who those customers are and then get their email address to send them a reminder that, hey, you haven't returned blah, blah, blah. So let's go ahead and try this out. First up, let's take a look at all the movies that are rented and not returned. So I'm going to say select start from rental, where rental dot return date is null. So this is how you check for blank. If it is blank, then you simply say is null. Null is database's way of saying there's nothing there. And these are all the rentals. So we have got 183 records here that have no return date available yet. So we now want to know what these inventory IDs correspond to. So here we can just start defining some aliases, and let's join it up now. Join inventory I on I dot inventory ID is equal to R dot. Now let's go ahead and define the fields that we want. The fields are rental date, customer ID, and then I dot film ID. Let's see this much. So these are all the movies. That is the date, customer ID is this, film ID is that. They have not returned because that's what the where clause is telling me. So let's go ahead and then see the name of the film. Again, you can join one more time, join film F on F dot film ID is equal to I dot film ID. And now we can access the fields from F dot title, and we're going to get all of these things. Now I'm going to sort this on title. So we can see order by F dot title, and we can start to see all the names in alphabetical order. I want to know if there is any movie that is kind of borrowed and not returned twice, like because we got 2 copies of that movie or something like that. So for example, here I've got Creature Shakes here. That's the name of the movie apparently. And the film ID is 189 in both cases. And customer 438 has 1 on loan. 570 has 1 on loan, both of which have not been returned. Suspiciously, the rental date time is also same. I guess this is what happens when you generate the data. So that is our 10th example. Now let's take a look at the homework example here. How much money and rentals we make for store 1 by day. Remember, in the ER diagram, you can see that there is a store table. So we actually have multiple stores. We haven't really thought about it so far, but we are only interested in all the business that is happening in store number 1. So I want to know what is the revenue that we are making and how many rentals we are doing on store 1 by day. And then as a bonus question, what are the top 3 earning days so far in the store 1? So go ahead and try this out as a homework problem and let me know in the comments how you're going with that. While SQL is great, it does have some problems. For example, the number 1 problem with SQL is not all data can be used with SQL. Let's say you have got data sitting in a SharePoint folder or in a PDF or on a web page. You can't just use SQL to access that. This is where the other popular data technology, Power Query, comes in really handy. So in our next topic, we are going to look at Power Query and answer similar kinds of questions, but with different data sources. We're also going to understand how to use Power Query to set up automations so that anytime your data changes, you can refresh the query and it will fetch you the updated data. I'll catch you in that one. Bye.